Yes, welcome everybody to our online platform. Our online platform is dealing with mathematical solutions. We are here to bring you a mathematical and statistical solution. Today, in our today's session, we are going to look at a topic of multiple linear regression. And we are going to cover the following. We are going to cover the meaning of multiple linear regression. We are going also to look when to use multiple linear regression, assumption of linear regression, and how to perform linear regression in Starter. Coming to our first subsection, what is the meaning of multiple linear regression? Multiple linear regression is a regressional model that estimates the relationship between a quantitative dependent variable and two or more independent variables using a straight line. That is multiple linear regression. When we come to when to use multiple linear regression, we have major use of multiple linear regression. The first place is to know how strong relation is between two or more independent variable and one dependent variable. The second, the value of dependent variable at a certain point of independent variable. For example, the expected yield of the crop at a certain level of rainfall, temperature, and fertilizer addition. There are the two use or two places that we apply linear regressional model. The next thing is looking over the assumption of linear regressional model. In assumption of linear regressional model, in multiple linear regressional model, there are a lot of assumptions. The first assumption is that dependent variable should be measured on a continuous scale. The second assumption, independent of observation, which can be easily checked by Dubit-Watson, yes, using assumption number 2, independence of observation. All observations should be independent, which can easily be checked by using Dubin-Watson statistic, which is a simple test to run using a software such as SPSS statistic. Coming to assumption number 3, two or more independent variable can be either continuous or categorical. Assumption number 4, there needs to be a linear relationship between an independent variable and each of your independent variables. Assumption number 5 states that there should be homoscedasticity, meaning that our data should show homoscedasticity. Assumption number 6, data should not show multicollinearity. Multicollinearity occurs when you have two or more independent variables that are highly correlated to each other. Yes. When we come to assumption number 7, there should be no significant outliers. Outliers are higher leverage points or higher influential points. That's what assumption number 7 talks about. When we come to assumption number 8 says that errors should be normally distributed. And the last assumption that we are going to look here is that no model misspecification. Assumption number 9 and the last assumption is that no model misspecification. Yes, I think assumptions are now clear, and we are now going to perform multiple linear regression in Starter. We are going to look how to perform a multiple linear regression in Starter. First of all, you must have a Starter application in your computer. with us, we have a start application, that we are going to look on. Here are our data. Here are our start application. Here is our start application, and we have different data here. The data that we are going to consider. The first thing, is that you must come to your file and example data set. We will come here and we will there under description we have a certain statement saying example data set installed with starter. We are going to click over there. Then there are several data that are going to appear. We are coming to use data number one, auto.dta. Here's the data that we are going to use, and we are going to see how to conduct multiple linear regression in starter. So we come here and use our data. We are coming to use it, and already it has appeared. It has appeared in this section. In here, our section, it has appeared. So here you can come and regress price, mpg, and wait. Then we can now enter. You can see there is a regression model that has been analyzed by the starter, and here are our result. Here is the result of our regression model for our data. Our data, we have obtained the result. If you can see, there is number of orbs which represent the number of observation. We were having 74 observation, and our model, we have 2 degree of freedom. The F statistic, the value of F statistic is 17.4, and the probability of F, we are much interested in the probability of F statistic, which is 0.0000. As you can see, we have 0.000. And when we come to R square, you can see it is 0.2934, and adjusted R is 0.2735. And root of mean squared error is almost 2,514. So here is the interpretation of our result. Let us begin with the probability of F. Probability of F is 0.000. This is the p-value for the overall regression. Since this value is less than 0.05, this indicates that the combined or explanatory variables of MPG and weight have a statistical significant relationship with the response variable, which is price. That is probability of F. The second thing is about R square. R square is 0.2934. This is the proportion of variance in the response variable that can be explained by explanatory variables. In this example, 29.34 of the variation in price can be explained by NPG and weight. Yes. Now let us come to the coefficients. If you come to the section of coefficients, there is MPG, which has a coefficient of negative 49.51222. What does it mean? Here is the interpretation. This tells us the average change in price that is associated with 1 unit increase in MPG, assuming that weight is held constant. Let me repeat, let me make it clear. Negative 49.512, this tells us the average change in price that is associated with 1 unit increase of MPG, assuming weight is held constant. Yes. In this example, each unit increase in MPG is associated with average decrease of about 49.15 in price, assuming weight is held constant. When we come to P, probability of T, the T value here, when we come to the T value of MPG in price is 0.567. This is the p-value associated with the test statistic for MPG. Since this value is not less than 0.05, we does not have evidence to say that MPG has a statistical significant relationship with the price. Yes, that is the case of MPG. Now let us do the second case, that is weight, the second variable, independent variable, that's weight. The weight has a coefficient of 1.746559. This tells us the average change in price that is associated with 1 unit increase in weight, assuming MPG is held constant. In this example, each 1 unit increase in weight is associated with an average increase of about 1.74 in price, assuming MPG is held constant. And the probability, the t-value, now let us look the t-value of weight. The t-value is 0.08, 0.008. This value, this is the p-value associated with the test statistic of the weight. Since the value is less than 0.05, we have sufficient evidence to say that the weight has a statistical significant relationship with price. Yes, that is the case of weight. There is a constant, the coefficient of constant. This tells us the average weight of the average price of the car when both MPG and weight are 0. In this example, the average price is 1,946 when both MPG and weight are 0. Actually, this does not actually make sense to interpret, since the weight and MPG of a car can never be 0, but the number of 1946.096 is needed to form regressional equation. Yes, reporting our data now, reporting the result of our data. When a sample of 74 cars was used in the analysis, the result showed that there was a statistical significant relationship between weight and the price, having a t of 2.72 and probability of 0.008, but there was not a statistically significant relationship between MPG and the price, having a t of negative 57 and the probability of 0.576. Yes, so after that, you will be ready and you will ready with your result. Will be ready with your result. And this marks the end of our today's session. For to enjoy the more coming session, ensure that you are subscribing our channel. Never forget to subscribe our channel. We have a team of mathematics experts that will give you a good way. Will contact you to a good path that you can swell to perform, to have a good and better performance in your mathematical and statistical study. Thank you and have a good day.